A molecular view of elements and compounds. So we've got elements and compounds. They are both pure substances. And then each of these can be divided. There goes my pointer again. It doesn't like this room. Each of them can be divided into subcategories. Elements can be atomic or molecular. Compounds can be molecular or ionic. It's out to get me. I think we're okay now. So different classifications. So atomic elements exist as single atoms, and this is most of the elements. Then there are molecular elements, and they actually exist as molecules when they are free elements in nature. There's a couple other ones, but the only ones we're going to talk about in this class are the diatomic elements. So hydrogen, when it is found as an element, is always H2. Nitrogen, N2. Oxygen, the oxygen gas in the air that we're breathing right now is not individual oxygen atoms, it's oxygen molecules. Two oxygen atoms bonded together. So those are these guys. When they are by themselves, they're two atoms together. I think of them a little bit as being like junior high girls. Someone pointed this out when I was in junior high, and I realized it was true. Junior high girls never go to the bathroom by themselves. You ever notice that? They always take a friend. I need to go to the bathroom, come with me. What is it? I don't know, they're insecure, right? So I think of these elements as being insecure. If you haven't noticed, I personify atoms and things a lot. So these guys are insecure. They never go out by themselves. They always take a friend. Okay? You need to know which ones are diatomic elements. I think I'll get to that in just a minute. So this is a picture of liquid mercury. Really neat stuff. Unfortunately, it's toxic, so we can't just play with it. But mercury is composed of individual mercury atoms. Here's chlorine gas in a flask. It is composed of chlorine molecules, not atoms. And that's the difference between atomic and molecular elements. So how do we remember those diatomic elements? Well, there's a couple of different ways. One is with this mnemonic, which is a silly sentence that helps you remember something. Horses need oats for clear brown eyes. So H, hydrogen, N for nitrogen, oxygen, fluorine, chlorine, Cl, bromine is Br. The only one that's a little bit iffy is this one. I's, it's I for iodine. So those are the 7 diatomic elements. You need to know those. They'll come up later. The other way is if we look at the periodic table and we find element number 7 is nitrogen, and if you make a 7 on the periodic table, those are the diatomic elements. Isn't that cool? There's 7 of them, and they make a 7 starting at element 7. I love it. Then what's up with hydrogen? Hydrogen has to break all the rules and all the patterns. And so here he is, off by himself on the periodic table, but he's part of that group as well. Okay, you got to know those guys. Compounds can be molecular or ionic. Molecular compounds, as I mentioned to you in lab briefly, are formed from nonmetals. So molecular compounds contain 2 or more nonmetals. The ones that we're going to learn how to name only have 2, but they can be 2 or more. Ionic compounds are going to contain ions, a cation and an anion. Usually ionic compounds are going to contain a metal. Okay, usually the cation is going to be a metal, but that's how you identify the difference between molecular and ionic compounds. So anytime we have a compound that contains a metal and a nonmetal, that's considered ionic. The basic unit of ionic compounds is not molecules, it's a formula unit. So these ionic compounds don't actually form molecules. You could really think of an ionic compound as being one ginormous molecule. They're like magnetics, those building toys with the little sticks and the magnetic balls. and they just stick together, and they make this three-dimensional lattice structure, and you can't really say, well, here's a molecule and here's a molecule. It's one big piece. And so we've chosen to describe it as the lowest ratio of the two ions together. And so that's the formula unit. Do I have a picture? No, I don't have a picture. That's okay. So we need to learn how to classify substances. So we're going to determine, are these atomic elements, molecular compounds, or ionic compounds? So chlorine. Well, first of all, is it a compound or an element? It's an element. And then, is it atomic or molecular? It's molecular. It's one of the 7. Horses need oats for clear brown eyes. Clear for chlorine. So this is a molecular element. I'm going to call that Me for molecular element. How about no? Isn't that what that is? Capitals shouting? NO. Is it an element? No. No. Because it's got 2 different elements in it. So it's got to be a compound. Is it molecular or ionic? What kind of elements are those? Are they metals or nonmetals? Nonmetals. It's just nonmetals, therefore it has to be molecular. So this is MC, a molecular compound. How about AU? You know how you remember the symbol for gold? That's what you would say when someone runs off with your gold watch. AU, come back with that. Yeah, okay. I got that from the Facts of Life a long, long time ago. So element or compound? Element. Looking at formulas, the kind of cheater way is look, how many capital letters? There's only one capital letter. It's an element. If there's 2 capital letters, that means there's 2 elements in it. It must be a compound. So this is an element. Is it atomic or molecular? It's atomic. It's not one of the 7. Na2O. Well, it's a compound, right? Because we got 2 elements here. What kind of an element is sodium? Metal or nonmetal? It's a metal. If there's a metal in there, the first one's a metal, it's ionic. So this is ic, ionic compound. CrCl3. It's got chromium and chlorine in it. Chromium is a metal or a nonmetal? It's a metal. So this must be an ionic compound. Any questions? We practiced doing that a little bit in lab, but if you can't identify what kind of a compound it is, then you can't name it successfully. It's not a situation where guessing works real well.